This is a brief lesson on the change of base formula. It's really important for solving logarithmic functions or logarithmic expressions that we can't solve in our head. Remember, we're limited by our calculator because we can't change the base on the calculator. We have to use base 10. So rather than worrying about having to do it in our head, we can use our calculator by changing our base, using this change of base formula to change our base to base 10. So I would write this down. This is the change of base formula. Let u, b, and c be positive numbers where b doesn't equal 1 and c doesn't equal 1. Then log base c of u. So given any log where the base is represented by c and we're finding it of u, the change of base formula says that I can divide log base u by log base c, and they will be equivalent. So this is saying no matter what this base is here, I can make it into bases that I know by using this formula, dividing u divided by c. So log base c of u equals log base u divided by log base c. Where this comes in handy is with this particular part. If that that change of base formula is true, then log base c of u is going to be equal to log u divided by log c. These are our common logarithms, and these are logarithms that we can use in the calculator. Using this change of base formula, I can calculate any expression that's in logarithmic form by using this formula. Same thing applies that if I'm given log base c of u, that is equivalent to ln of u divided by ln of c, the natural log of u divided by the natural log of c. So we can use these in particular to apply them to our calculator. But it is very important to know how to change bases, because maybe you want a base that you want, like 2. We can work with base 2 a lot easier than we can work with base 17 or base 122. So one example you might get is evaluate log base 3 of 7 using common and natural logarithms. Now I can't simplify this because there's no way for me to put 7, the number 7, in terms of 3 to some exponent. There's just no equivalent. So I can use my formula. Log base c of u is going to equal log base b of u divided by log base b of c. The way we can apply this is that if I have log base 3 of 7, this is equivalent to, now I want common logarithms, so I'm going to use base 10, log base 10 of u, which is my number 7 here, so log base 10 of 7 divided by log base 10 of c, which is what my 3 is. Now this is also equivalent to log of 7 divided by log of 3, which if we put into our calculator is going to be about 1.771. Additionally, we can use that using natural logarithms the same way. Log base 3 of 7 is going to be the same thing as ln of 7 divided by ln of 3. Using the previous slide where we said since the bases are going to match, we can use our common and natural logarithms. This is going to be about 1.771 using your calculator. As you can see, they're equivalent. They should be. They're both representing log base 3 of 7. Okay, I want you to pause the video and try these 3 problems on your own. You can use your calculator once you've already gone through the change of base formula. Okay, looking at these, starting with the first one, we have log base 5 of 7. That's going to be log of 7 divided by log of 5. If you put that in your calculator, you should get about 1.209. Looking at the next problem, we have log base 3 of 16. That's equivalent to log of 16 divided by log of 3. If you put that in your calculator, you're going to get about 2.524. Finally, we have log base 4 of 19. That's equivalent to log of 19 divided by log of 4. If you put that in your calculator, you should get about 2.124. So if you got all three of these correct, you understand how to use the change of base formula. And all I can really emphasize to you is that it's important you memorize this formula because you're going to need to be able to reproduce it pretty quickly, just like you do with changing from exponential to logarithmic and vice versa.